Hey, what's up you guys? It's Mr. Olson. For the start of this chapter, we're dealing with this thing called quadratic equations. And as you guys already know, we've been doing quadratic formulas now for a couple weeks, so we're kind of continuing on that theme. And a quadratic equation is any equation that you guys can write in the form ax squared plus bx plus c, which is what we've been dealing with already. And we like to set it equal to 0. It has to be able to equal 0. So that doesn't mean a whole lot when you see it with all the letters. So let's take a look here. Here's an example of something that's a quadratic equation. Take a look at this blue one. We've got our negative x squared minus 4x minus 4 equals 0. Obviously, we have that nice little x squared here, so it's a quadratic equation. This red one is not a quadratic equation. And hopefully you can see because there is no x squared anywhere in here. That's just a simple linear equation. Alright, so quadratic equation looks something like this here, and here's a good example. Now, to solve a quadratic equation, notice that this quadratic equation equals 0, right? So we need to figure out how to solve to find out what value of x gets this whole equation to equal 0. Now, this is a lot to think about. Okay, so we're going to take this to something that we're familiar with. We're going to shift this to a graph. Alright, so as you can see here, this is a quadratic equation. Alright, because it does have that x squared in it. And in order to see what numbers makes this thing equal 0, hopefully you guys can remember a quadratic equation might look like this, or it might look like this. Alright, which one are we looking at here? Is this one going to be an upward U or a downward U? Alright, hopefully you said out loud, it's going to be downward because it's negative with me. So we know this thing on a graph is going to look something like that. Alright, so what we're going to do is we're going to get rid of those for now. And if you remember from last chapter, the best way to graph a quadratic is first and foremost, we need to find the axis of symmetry. Alright. Sorry for my spelling. We're going to find the axis of symmetry, which is negative b over 2a. And in this case, our b is negative 4. Alright, so here we go. Negative 4 over 2, and our a is just a negative 1 here. Check it out, negative 1. So a lot of negatives here. Negative 4 is going to be positive 4. And 2 times negative 1 is going to be negative 2. So 4 divided by 2 is 2, and there's still a negative, so it's negative 2 is our axis of symmetry. That means somewhere along this line is our vertex, and our graph is going to have a center on here. It might look like this, or this, or this. We just know that it has to be centered along that axis of symmetry. Alright, now our second step here, oops, got to redraw my axis. Our second step here is now that we know our axis of symmetry, we've got to actually find our vertex. So, now that we know our axis of symmetry, vertex, actually pretty simple. To find the vertex, we plug in our axis of symmetry. So we're going to plug in negative 2 into our equation. So here we go. I haven't done this yet, so it might be kind of complicated. And we have negative 2 squared, right? We plugged in negative 2 for x. Minus 4 times we plug in negative 2 here. Minus 3. Alright, it's getting a little complicated. This is going to be negative 2 squared is positive 4. We got this negative out front, so it's negative 4. Negative times negative is a positive 8. Minus 3. I can tell doing some quick mental math that we're going to get 1. So our vertex is at negative 2 comma 1. There it is right there. This is our vertex. Everybody see that up in your graph here? Alright, now we have one more thing to go before we can actually start graphing this, and that is to just find a couple other points. So as I look at this thing, I'm like, you know what? I see negative 1 is on this side and negative 3 is on this side. So I know that whatever I get for one is going to be the same on the other because it is symmetrical on either side. So I'm going to plug in negative 1. Okay? Plug in negative 1. I want to see where this point is at negative 1. You guys could pick any number in the whole world. Alright? So if I plug in negative 1, here we go again. same equation, I'm plugging in -1 for this problem. Alright? And as I do that, if you guys want to slow this down and do it yourselves, you can. I'm going to go kind of quick. This will equal -1. -4 times -1 is +4 minus 3. Looks like when I do this, I get 0. So I'm going to put that dot on my graph here. -1, 0. Which means, since my graph is symmetrical on either side, that means -3, 0 will also be the same. And we have this nice looking graph that's going to go like this. Alright, and as you can see by graphing it, what are my zeros? Well, if you remember from last chapter, we got one of them here and one of them here. So this point here is -3, 0, and this point here is -1, 0, meaning my zeros are at -3 and -1, which means my solutions to this problem, the two numbers that I could plug in to this quadratic equation to make my equation equal 0 is I could plug in -3 or -1. Those are my answers. And as you can see, this graph has two zeros. It has a 0 here and a 0 here. Now real quick, and this is the last thing, is for my graph, sometimes you might have a graph that looks like this. How many zeros does this graph have? Hopefully you can see it only hits the x-axis one time, so it'd be 1, 0. Occasionally you'll have a graph that may look like this. Does this ever cross that x-axis? It does not. So this graph here, we would say has no solution or no zeros. Alright, and that's pretty much it.